Hi guys, welcome to the data structures and algorithm journey. So in this video, we will be learning about what are data structures and its type. So let's get started. What are data structures? Data structures are a way of organizing and storing data in computer so that it can be accessed and used efficiently. Data structures are very essential for developing efficient algorithms and can be used for managing large amount of data. Data structures are divided into two categories: linear data structures and non-linear data structures. Okay, so let's understand these categories one by one. So what are linear data structures? Linear data structures are those in which data elements are arranged in sequential order. And some common types of linear data structures are array, stack, queue, linked list. To understand linear data structure, let's take an example of shopping list, where items are arranged by one. Okay. Another example of linear data structure is music playlist, where songs are arranged in specific order and played one by one. Now let's understand array data structure of linear data structure. Array are the simplest data structures and are used to store collection of elements of same data type in contiguous memory location. So array data elements are stored in contiguous memory location. Array can be fixed or dynamic size and can be accessed by using index. For example, you can see here, this is number array, okay, and in this number array, it is having indexes. So to access number 5, you need to use index 2. Array are very useful for implementing algorithms that involve searching, sorting, and manipulating large amount of data. Stack data structures. Stack data structures follow last in, first out principle, which means last element added to the stack will be removed first. So here an example, here 1 is added to the stack first, then second, then third. So to remove it from the stack, we need to first remove 3, 2, then 1. So various applications of stack data structures are undo redo functionality in text editor. Then you can, in browser, you can go forward, backward. Okay. It can be also used in recursive functions and expression evaluation. Queue data structures. Queue data structures follow the principle of FIFO, first in, first out. Okay. And the element from which the elements are added, it is called as rear front. Okay. And the items from where the items are removed, it is called front. Okay. And best example of queue is bank queue. People stand in queues, right? So you can think of queue like that. Okay. Queues are having various applications such as implementing scheduling algorithms, handling web server requests. Okay. So this is an example. Okay. Where we add elements and remove. 3 is first added, that's why it is 3 is first removed, then 1, then 2. Okay. Now let's understand linked list data structures. Linked list are the dynamic data structures that consist of sequence of node and containing data elements and a pointer to the next element. Okay, in a sequence. So here is an example. Here we are having a data element which is pointing to another data element, and that data element is pointing to the another data element. Okay. Linked list can be used to implement stack, queue data structures and various other types of data structures. If you see in array, we cannot remove mutable elements. Okay. So in linked list, we have that functionality where we can insert as well as delete elements from the middle of the sequence. Now let's understand non-linear data structures. So non-linear data structures in which data elements are not arranged in sequential order or non-sequential order. Instead, they are arranged in hierarchical manners, okay, where one element is connected to another element which can be more than one or more, okay. So some of the common types of non-linear data structures are tree, graph, hash tables. For example of non-linear data structures, we can understand it using family tree, where we can have grandparents, then parents, then children's. Okay. One more example is computer network. Okay. So now let's understand tree data structures of non-linear data structures. Tree are hierarchical data structures that consist of node. Okay. So one is the node and it is connected by edges. So one is connected by edge to 3. Okay. One is also connected to 2 by this edge. Okay. And some of the various applications of tree data structures are file directory. So file directory, let's say you are having a folder, in that subfolders, in that more subfolders. Okay. Tree data structures can be also used for searching algorithms and data compression. Okay. Now graph data structures. Graph data structures that represent a set of objects, nodes and vertices, and connected by links, okay, edges or arc. Okay. So here 0 is connected to 3 by this edge or link, 0 is connected to 2 and 0 is connected to 1. Okay. Here there is no hierarchical manner. Okay. And graph data structures are used in various scenarios, where real world scenarios like social media network. Then one of the best example of graph is Google Maps. Okay. It can be also used in road networks, airline routes. Okay. Hash tables. Hash tables are the data structures that uses hash function, okay, to map key, okay, to indexes of array, okay, where the corresponding value is stored. Okay. Hash tables are having various applications such as database indexing, cache management, spelling checking. Okay. So in summary, we can say that linear data structures are the data structures in which data elements are arranged in sequential order, well as in non-linear data structures, elements are stored in non-sequential order or not arranged in sequential order. Linear data structure examples are array, stack, queue, linked list. Non-linear data structures are tree, graph, hash tables or hash map. Each type of data structures are having its own advantage and disadvantage. But the choice depends on us, on a specific need where we can use efficiently to solve a problem. Okay? So the next topic will be asymptotic notation. If you like our video, please like to our video, share it with your friends, comment below and subscribe to our channel. Thank you.